Please make sure that you put parentheses. Because there is only one term, at the top, you can get away without parentheses for this, but you already know me, I will not miss chance of putting parentheses somewhere. So then x squared minus 4. Parentheses are on top, parentheses are on bottom. Zoom, again, zoom 6. Just show me the graph. Here it is. Here it is. Here it is. As expected, from 0 to negative infinity, from positive infinity crossing at the origin, going to negative infinity. So these are way more sophisticated functions, as you see. This is not a quadratic trajectory. Okay. And then I'll show you, let me show you a couple of examples that I already mentioned before we look at type 3. Here it is. Oh. Okay, here's a graph. Let's look at this function. 6.5x squared minus 20.4x plus whatever, x squared plus 36. What type of function is this? Type 1 rational function. What will be the horizontal asymptote for this function? Leading coefficient over the leading coefficient. What is it?
6.5.
The leading coefficient is 6.5, right? Is that what you said, Kyle? Okay, sorry, I didn't hear. So maybe I need a hearing aid. I hope not. 6.5 divided by 1. That's the horizontal asymptote. Okay, perfect. So now let's read the problem. It says, this function models the pH level, as I mentioned earlier, f of x of the human mouth x minutes after a person eats food containing sugar. The graph of the function is shown in the figure. So now let's look at the graph for a moment. It starts somewhere at 6.5. It drops dramatically. It has a turn. And it comes back approaching 6.5 eventually. So if this represents the pH level, if I take sugar, I swallow a piece of sugar or anything, candy, whatever, with sugar in it, and the pH level in my mouth will drop from 6.5 to apparently, I don't know, 4.6, 4.7, something like that, within 6 minutes. And it will take almost an hour. I don't know if that means anything for our mouth or not, or if, it has any consequences. But it takes almost an hour according to the model, and the model is created based on studies of people eating sugar and their pH level being measured, right? So they came up with this. It takes almost 60 minutes for the pH level in the mouth to get back to normal. Okay, use the graph to obtain a reasonable estimate to the nearest tenth of the pH level of the human mouth 42 minutes after a person eats food with sugar. 42 minutes, I have no idea. I'm going to say 6. pH level is 6. No measurement unit for pH. After eating sugar, when is the pH level the lowest? Right here, 6 minutes, right? 6 minutes after we swallow sugar, whatever. Use the function's equation to determine the pH level to the nearest tenth. I would have to put in the function. According to the graph, what is the normal pH level of the human mouth? 6.5. What is the equation of the horizontal asymptote associated with this function? Y equals 6.5. Use the graph to describe what happens, which we already did. Okay, here's another one. Again, this is sophisticated stuff. Okay. A drug is injected into a patient, and the concentration of the drug in the bloodstream is monitored. The drug's concentration, C of T, which is this, in milligrams per liter, after T hours is modeled by this function. What type of function is this? Exactly. Because we really hope that after we take some medication, eventually the concentration of the medication in the bloodstream approaches, we really hope so, right? It gets out of the system. So that's why they fitted, for this particular situation, they fitted a type 2, which makes sense. Okay, use the graph to obtain a reasonable estimate of the drug's concentration after 3 hours. Now careful, when you read something like this, at the bottom it says 0, 10, 0, 10, 1. So all these represent 1 unit. 0, 3, 1, 0, 3, and 1 unit. So at 3, 1, 2, 3, I'm going to read 1.5. 1.5 milligrams per liter after 3 hours, still in the bloodstream. Use the functions equation displayed in the voice balloon to use, okay, so when I plug in 3 here, do I get 1.5? 5 times 3 is 15. 3 squared is 9. 9 plus 1 is 10. Is 15 divided by 10 1.5? Yes, it is. Use the functions equation to find the horizontal asymptote. What is the horizontal asymptote of this function? Y equals 0 because it's type 2. Good. So these are a couple of examples in which that use rational functions as models to model real-life situations. So do you think we should look at another example of type 1 and type 2, or should we move on to type 3? We move on? Okay. Very good. So type 3. Type 3 is a little bit longer because of that slant asymptote. For that reason, as I said before, I repeat myself a lot. I will not ask you to maybe homework will be there. It's possible. That's why I need to show you at least one example. I don't have control over that. As I mentioned, I did not create the my math lab assignments. The department did. So it's possible that you may encounter one. I will put one problem on this test coming up as an extra credit to choose from. Okay? So here's our type 3. X squared plus 3x plus 2. It's not difficult, but it's long. Okay. What do you think I'm going to do first before I even talk about it? Awesome. Always remember, factor simplify should always be in the back of your mind on everything. So, perfect. Thank you for saying that. And I get my chart, my table going. The most interesting applications in this class, however, I think you will find them in Chapter 4, in which we will discuss 2 more functions that have tremendous applications in real-life situations. From our interest rates, or not, I shouldn't say interest rate, I should say monthly payments for mortgage or car payment or whatever loans we have, to how a turkey cools down when we take it out of the oven before Thanksgiving dinner. All those applications are in Chapter 4. From earthquake, modeling earthquakes, just everything, really. I shouldn't say everything, a lot. Good. Tell me what you can say about the top. Awesome. Thank you. So now I need the domain, please. Very good. Is that clear that x cannot be 1 in this function? Okay, perfect. So does x minus 1, the next example I will show you with that situation, that exception. Does x minus 1 go away with any factor of x minus 1 from the top? No. Therefore, x equals 1 must be vertical asymptote. Once we say that, what do we have to write left and right immediately, automatically? Yes. What we don't know is if it's positive or negative. So let's plug in 0.9. I hope you agree with either one, the numerator will always be positive. With 0.9, or 1.1, the numerator is always positive. It will not create any problems. Would you agree?
Yes.
But what happens with 0.9 though? Negative. And what happens with 1.1? Awesome. Excellent. Perfect. Now, since we're here, let's plug in 0.
So -2.
Very good. Can anyone give us the X-intercepts?
-2 and -1.
Correct. When the numerator is 0, the fraction is 0. So f of x equals 0 means x plus 2 times x plus 1 equals 0, and the two options are -2 and -1. And -2, 0, -1, 0. The function cannot be symmetric because it has a vertical asymptote at 1. We're going to write that. Let's write it now. And then we have one more step. So f of x is not symmetric. Okay. Final step. We know that this is type 3. It will not have a horizontal asymptote. But how do I determine the slant asymptote? I have to divide. I have to divide the top by the bottom and find the quotient and the remainder. That's why we looked at 3.3, division of polynomials. How do you want to divide top by the bottom? Is synthetic division applicable here?
Yes.
Yes. Do you want to use long division? Do you want to use synthetic division? It doesn't matter. Long division? Yes? Very good. So are they both in descending order? Is there a missing term from the top? No. So I have x squared plus 3x plus 2 divided by x minus 1. Okay. So first step. X times what is x squared? Very good. So let's go back and distribute. Exactly. So because it's positive x squared, but we have to change the sign. And then I have negative x, but I have to change the sign. Bring down the next in line.
+4.
Plus 4. At the top, we do not lie. So now 4 times x is 4x. I have to write. Very good. And 4 times -1 is -4, and I write +4. So then, this division of x squared plus 3x plus 2 over x minus 1 has a quotient which is
X plus 4 with the remainder of 6.
plus 6 divided by x minus 1. Only this portion is of interest right now. Y equals x plus 4 is the slant asymptote. And you can say, what happened to this? Nothing. When x approaches infinity, this is the quantity. This will approach 0. That's why we don't even look at it. So I will write y equals x plus 4 slant asymptote. And now I will identify the end behavior. When I graph x plus 4, y equals x plus 4, do I graph it like this? Or do I graph it like this? Number 1 or number 2? Number 1, because it's a positive slope, right? Slope is 1. So it's this. This will also be the behavior, the end behavior of the function. It has to follow the asymptote. So then, it's negative infinity to infinity. Now, if you say, gee, this is weird, I will have to agree. At first look, it looks weird, right? First of all, this side. How is it possible? How can I connect this? No, I won't. I connect it like this. There is no function that connects infinity, but it does with a minimum. So this piece will have a minimum. But what about this piece over there, all that thing? So from negative infinity, it will cross the x-axis twice, the y-axis, and then come down to negative infinity. So initially it was iffy, but to understand, or difficult to understand, but it's really not. Okay. When we graph a function with asymptotes, what do we have to graph first? The asymptotes. How many asymptotes are we going to graph for this function? Yes. Let's start with this one. How do I graph y equals x plus 4? When x is 0, how much is y? When x is 0, y is? Good. When y is 0, move 4 to the other side. Negative 4. So here's the first asymptote. The slant, y equals x plus 4. Which other asymptote I have to graph? Yes. Let's graph the vertical asymptote, which is at 1. Ready? I will have to plot negative 2, 0, negative 1, 0, and 0, negative 2. So let's see what the table is telling us to do. From approaching the asymptote at negative infinity, it's crossing at negative 2. It has to have a turn somewhere here. Crossing again at negative 1, 0. Crossing at 0, negative 2, and going to negative infinity. So from negative infinity, crossing at negative 2 has to have a turn because it comes back and crosses again. And approaching, crossing the y-axis and approaching negative infinity. This side, there is a big question mark here, of course. Yeah, I know that is not a problem. It has to have a minimum. Again, I repeat myself, like always. I think that this particular function is beyond the scope of this course. Let's graph it together, and we can determine the max and min with a calculator. I do this with my calculus class. It just finished. I'm going to do this next week with them. But it's a totally different story at a different level, and we are using different technique, totally different technique than just talking about the function and looking at the graphing calculator. Okay, so here it is. So clear everything. How many functions do I have to put in? 2. What is the second function? Exactly. Awesome, thank you. Great job. X plus 4 is the second function. Now be very careful how you put in the first function. We have to have parentheses around the top. We have to have parentheses around the denominator. So x squared plus 3x and plus 2. Very good, thank you very much. And divided by, in parentheses, I think it's x minus 1.
Is there a way you can cheat the vertical asymptote?
With the software? If you want to play,
really big number
if you want to play with it, please show me.
If you do like a really big number plus x, and then or a really big number x.
Know how to determine the signs?
No, like to graph a vertical asymptote.
Okay, go ahead. You can come over here and teach me.
Oh, like a large.
In just 1 second. So here it is. That I have to adjust the viewing window because I can't see that piece. Okay? So obviously I know this is not flat here. It must cross, have a turn, and come back. So I'm going to adjust the viewing window so I can see this. I'm going to go higher and to the right. So with a viewing window, let's say 30, with a scale of 6. And I want to the right, maybe 20, although I think I'm okay. I see it, with a scale of 5. Here it comes, and here it comes. And now the slant asymptote. Okay, Kyle, if you want to try, go ahead.
Just put like any like large number and x plus 1, or the vertical.
You mean here?
Hmm?
Here?
Like if you make another equation.
I can't. X is anything with x is not a function.
not like a legit way, it's just a way to view it.
I have no idea what you're saying. Teach us. Go ahead. It's right here, under. Okay.
So, gives you 0. Oh, I see what you're saying.
So,
Yeah, so basically you're making an equation where you add the.
no, but there is a way of, but in some calculators, I don't know in the software, I haven't tried. But good try, but thank you. Okay. Any questions? Any questions on this? Okay, I will not ask you to do this. Mandatory. So it's too much, it's not complicated, but it's too much work. And I don't want you to focus on this for the test. Unless you like it and unless you want to choose this problem as the extra credit. Now I would like to go back to either type 1 or type 2 and take a look at the following function. Okay, is this function type 1 or type 2? Type 2, which we know exactly that the horizontal asymptote will be? Awesome, very good. What do you think I am going to do immediately? Yes, x minus 1 over. Remember, you cannot touch the function before you state restrictions. Do not do anything other than factor it. You cannot do anything before you state the restrictions. What are the restrictions for this function? We agree? Only now I'm allowed to do this. And the answer is 1 over x plus 1. The simplified form of this is this. It doesn't mean that we changed the function. We didn't. We simplified it, but we stated the restrictions before we simplified it. Good. So now, let's start our table. Can anyone give us a domain of this function? One more time, negative infinity to negative 1, union. And what happened between negative 1 and 1? There are infinitely many numbers I can skip. Yes, union. Awesome. So negative infinity to negative 1, 0 in the middle. So the function is undefined in these situations. Of course, you already told me I'm going to take advantage of that to finish that up quickly. So now we have to analyze what happens. Let's take a look at x equals 1. In other words, the factor x minus 1. Did the factor x minus 1 disappear?
Yes.
From the final simplified form? That because x minus 1 is not in the final answer, in a simplified form, it will not be a vertical asymptote, but a hole in the graph. So the factor that goes away becomes a hole in the graph, not VA. The factor that stays, which is x plus 1, in other words, x equals negative 1, this can never be changed into anything but a VA. If the factor stays, it's a vertical asymptote. If the factor goes, it's a hole in the graph. So once we say VA, what do we write immediately, left and right? Perfect. I only have to identify which one, because I don't know the sign yet. But I will use negative 1.1 and negative 0.9. So let's plug in the simplified form, negative 1.1, and just give me the sign of this expression. Don't calculate anything, I only need the sign. Perfect. Please plug in negative 0.9. I only need the sign of the expression when I plug in negative 0.9. Positive. Perfect. Now what do I do with the hole? because I have here and here, it has to be the same number. Here's how I determine this number. By plugging 1 in the simplified form. Give me the answer, please. That's it. So 1 comma 1/2 will be the hole in the graph. 1 over 1 plus 1. 1 plus 1.
Okay.
So now let's plug in 0 for the y-intercept. How much?
1.
Exactly. This is it. Ready? When we graph functions with asymptotes, what do we have to graph first? That's it. So in this case, I'm going to graph. There is no need for this, but if you want, you can write y equals 0. There is a x equals -1, a vertical asymptote. And I am going to plot the hole. So if this is 1, 1 comma 1/2 is here. And I have to plot 0 comma 1. Okay, let's come back. Let's see what this means, what it says. From approaching 0 down to -infinity. From +1, crossing the y-axis at 0, 1, going through that hole at 1 comma 1/2, and then approaching 0. One more time. From the right, 0, down to -infinity. On the other side, from +infinity, crossing the y-axis, going through that hole of 1, 1/2, and then approaching 0. That's the graph. So 0, -1/2, 0, -infinity. Right here. Done. On the other side, from +infinity, crossing at this point, going through that hole, and then approaching 0. And this is the graph of x minus 1 over x squared minus 1. Make sure that you plug in the graphing calculator the original function. So now let's take a look. In y equals clear, everything you have. Oops. Please go up. Thank you. Please make sure I put parentheses around the top, which is x minus 1. Close the parenthesis and divide by close the parenthesis, open a parenthesis, x squared minus 1. Okay? I'm going to use the standard viewing window for this first level, and we'll see in a minute what we see and what we don't. It's coming from 0 going to -infinity. It's coming from +infinity, crossing at 0, 1, going through the hole. In a minute I'll show you, and then approaching 0. So now let's zoom in. I only care to see this piece right here. So between 0 and 2, and between -1 and 2. So window, 0 and 2, with a scale of 1, -1 to 2, with a scale of 1. Ah, here it is. It's very clear it's not a vertical asymptote, because the function would have had to do this. It doesn't. So it's a hole in the graph, because that particular factor went away. If it had stayed, it would have been a vertical asymptote. Any questions? Any questions? Any questions? Any questions for me? So we have 6 more minutes as we discussed, so I would like you to tell me what you would like me to do. You would like to look at the type 1, you would like to look at type 2. For those of you who may be behind a little bit, if you'd like to go back to a polynomial function, if you'd like to graph another polynomial function. Yes? Okay, let's choose a degree, any degree you want. So let's choose a polynomial function of degree such and such. Is it even? Is it odd? What would you like? So what is left for Thursday is section 3.6. I need about 10 minutes for that. Basically, it's just a little puzzle that I will show you. I think it's going to be very, very simple. Maybe 15 minutes, let's say, with some examples, and then we'll start reviewing for test 2. It's a week after Thursday. If we review everything and we finish, then I will still keep it for Thursday, but I will start chapter 4. We have chapter 4 and a little bit of 5, 6, and 8 before test 3. Okay, so 3.6 is for Thursday. So any polynomial, any particular degree, which one would you like? Odd degree, even degree?
3.
Degree 3? So an odd degree? Okay, very good. So let's take a look. So let's say negative x times x minus 1 squared. What type of function is this? Polynomial, degree. Very good, because I have x squared times x is degree 3. Very good. How many terms can this function have? Maximum. Maximum 2. Maximum 2, maximum n, whatever they could be. I get my table going. What is the domain of this function? Remember not to confuse with what we just did. This is a friendly function. It doesn't have horizontal asymptotes. It's always defined. It doesn't have vertical asymptotes. Very friendly. So negative infinity to infinity. Before I forget, I gave out this today. I'm kindly asking you to work on these problems between now and Thursday and finish up as much as you can so we can review and be as solid as possible. Okay? Everyone else? Okay. I don't think I gave one to Sean. Okay. Good. So X-intercepts, please. So y equals 0 or x or negative x, x minus 1 squared equals 0. And you're going to give how many? Indeed, 3. Degree 3, 3 solutions. So, what is the multiplicity of solution 0? Perfect. What will the function do there? Very good. What is the multiplicity of x equals 1? 2. What will the function do there? Yes, or turn. Very good. Awesome. So for 0 is 0, and for 1 is also 0. This is a cross, and this is a turn. Because it's degree 3, it will be compared for the end behavior, just for the purpose of the end behavior, or finding the end behavior, it will be compared to the linear function with the positive slope or the negative slope. Negative slope, because the leading coefficient is negative. So how do I graph a linear function with a negative slope? Number 1 or number 2? Number 2, and that's the end behavior. Is this function symmetric? No, not possible. If it's crossing at the origin and turning at 1, not possible. Okay, I will write not symmetric. But be very careful when it is. You have to show the whole work. Okay, so now let's graph. Does this function have asymptotes? No, it's polynomial, very friendly. Okay, 0, 0, and 1, 0. Let's see if we can make sense of this. Here's what I see. It's coming from positive infinity. It's crossing at the origin, but it has to come back and turn because you will eventually turn at 1, 0 and go to negative infinity. One more time. From positive infinity, it's crossing at the origin, but it has to turn because it has to come back and turn again at 1, 0 and then go to negative infinity. From positive infinity crossing, coming to a minimum, has to come back and turn at 1, 0 and go to negative infinity. So this is f of x equals negative x minus 1 squared. Yes, I should be determining this minimum with the graphing calculator. So we'll put in the graphing calculator and determine that minimum between 0 and 1. And with that occasion, we will check everything to make sure that we didn't miss anything. So negative x, and in parentheses x minus 1, and it's squared. And I will be using zoom 6 again. Here it's coming, crossing, turn. Of course, this is a lie. It's not that flat. It has to have a minimum. So I will determine the minimum between, so with second and calc, I want a minimum which is number 3, and between 0 and 1. And I don't want to guess. So the minimum is at 0.33. You don't have to go back and adjust the graph. Negative 0.148. That's all I care about. Of course, negative 1.8 cannot be this big, right? Depending on, so this is 1, and this cannot be negative 0.1. But you don't have to go back and do anything. Just point to the graph, and I'm more